Welcome to this lecture series in coordinate geometry on straight lines. In this lecture and the next, and perhaps even the next to that, we will be discussing the equation of a line. In this lecture, we'll keep things very basic. We will look at what is meant by the equation of a line. And in the next lecture, we will be deriving the equations of various forms. Anyway, so all we need is just some basics of the coordinate plane. So if you know what is the x-axis, what is meant by the abscissa of a point, etc., it's enough. And with that, here are some problems for practice. And now let us get started. So let me illustrate what is meant by the equation of a line by means of an example. So here I have the coordinate plane, and there is a line passing through the origin. And let's say it makes an angle of 45 degrees from the positive direction of the x-axis. So what we want to do is the following. Suppose I know that there is a point here, P. Let's say there is a point P here. And somebody has told me what is the abscissa of this point. Suppose I know the abscissa to be, let's say, 2. Can I deduce what is the ordinate? So that's very simple. Just drop this perpendicular. And if the abscissa is 2, this length is 2. And since this is 45, this is also 45. So this is an isosceles triangle. And hence this length is 2. So if the abscissa is 2, the ordinate is also 2. And you can play this game for any point P. So if the abscissa were x, the ordinate will turn out to be x. So this is what is meant by the equation of a line. Y equals x describes perfectly every point on this line. Meaning the set of points on this line are precisely those points where the y coordinate equals x coordinate. So this basically that is the meaning of the equation of a line, right? If you want to write the set, the set of all the points on this line, it would be written this way. If you know the set builder form, otherwise ignore it. So if you know the set builder form, then this makes sense to you. Otherwise, this does not make sense and you can ignore it. But I hope it is clear what is meant when we write y equals x now. So those points where y equals x are precisely the points on this line. And yeah, that's it. So let's take one more example. Oops. Yeah. So now my line is horizontal, passing through this point 0, 3. Can I describe all the points on this line? So here, if I'm told the abscissa, I can of course tell the ordinate, because the ordinate of every point on this line is 3. This line is parallel to the x-axis and passes through this point. So all the points on this line have ordinate 3. So if I were to express the points on this line, I would just write y equals 3. That is a perfect description of every point on this line. Every point which satisfies this equation is on the line, and every point on the line satisfies this equation. So here you don't see any little x featuring in this equation because there is no need for it. You can write a 0x if you like, but there is no need for it. Now let us look at this example where you have a 45 degree line passing through this point 0, 2. So if I'm told the, let's say, abscissa of some point, suppose I'm told that this is x, then this is also x, and hence this is also x, but this is 2. So this point becomes x, x plus 2. Right? So if I know the abscissa, if the abscissa is x, the ordinate is x plus 2, and therefore the equation of the line would be y equals x plus 2. And you can check that every point here, every point that satisfies this equation. So for instance, if x is 1, then y better be 3, and you can actually draw it out and see that 1, 3 is lying on this line. Okay. So I hope this is clear. And in the next lecture, we will deduce, we will be a little bit more technical with all these things. And let us review or maybe look at one concept that you may have seen earlier in your high school, but let's do it from the beginning. So, slope of a line. So, I have the coordinate plane and a line. Then the slope of the line is defined as the tan of the angle between the line and the positive x-axis. So what I mean is this: suppose this angle is theta, the angle made by the line and the positive direction of x-axis, then tan theta is defined as the slope of the line. Okay, that's it. That's the definition. Okay. So let's see some examples. So here my line is horizontal, and therefore here the slope is 0. Generally we write m to denote slope, so m is 0 here because tan 0 is 0. Here m equals tan 60, which I believe is root 3. Yeah, it is root 3 by 2 divided by half. It is root 3. Here m is tan 90, which is infinite. So the vertical lines pose a little bit of a problem here because you cannot really do algebra with the symbol in any meaningful way. So they do cause some problems, but it is what it is. So here the slope is infinite, and here the slope is tan 135, which I believe is minus 1. It has to be minus 1. So slope can be negative, positive, infinite, 0, anything. Okay. And let us also look at one special case. So suppose we have two lines and they are, let's say, perpendicular. Then one can write down a relationship between their slopes. We are assuming that none of these lines are parallel to the y-axis, so that none of these slopes is equal to infinite. And with that assumption, we want to show that. So m1, m2 is minus 1, where by m1 we mean m1 means the slope of this line, which is tan theta 1, and m2 means the slope of this line, which is tan theta 2. So this is what we want to show, but this is, obvious, because what is theta 2? Since these two lines are perpendicular, theta 2 is 90 degree plus theta 1, everything is in degrees. So tan theta 2 is tan 90 plus theta 1, which is minus 1 upon tan 90 plus theta 1. Sorry, minus 1 upon tan theta 1, just basic trigonometry. And this immediately gives us that m2 times m1 is minus 1. That's it. So if we have two perpendicular lines and none of these are parallel to the y-axis, then the product of the slopes is minus 1. The converse is also true. So if you have two lines whose product of the slopes is minus 1, then they are necessarily perpendicular. And you can just these steps to get there. And I leave that as an exercise. So this is something that we should know. And with this, I want to end this lecture. As usual, like, comment, share, subscribe, and I'll see you next time.